Hello, everyone. Welcome to another wonderful episode of Cuda Education. I'm your host, Nicholas Main. Today, what I'm talking about is Cuda Graphs, which is the latest feature to come out of the NVIDIA camp for Cuda GPU programming. The purpose of Cuda Graphs, of course, is to have faster applications to make your processes run quicker and also to make it repeatable. In CUDA programming, of course, we launch kernels, and the kernels are really fast because it's parallel programming or what have you. But previous to CUDA graphs, if you wanted to launch many kernels, you would sort of have to go through the entire initialization and CPU overhead process of launching each individual kernel or sets of kernels or however you do it. But with CUDA graphs, you could predefine all your entire process and predefine it, instantiate it, and then execute it at will. But not only execute it once, you could repeatedly execute it, and it's a lot faster than doing it without CUDA graphs because everything is the graph is already initialized, it's already defined. The overhead is already done the first time around. So all you have to do is simply repeat the processes that you're doing. So it sort of takes out a lot of the overhead that you need in order to do repeat work. And then also even for short kernels, it's faster because you can the work is predefined, the program, the compiler, everything that's dealing with the GPU, everything that's dealing with running your program, it's already visible to the program before anything is launched. So there are certain optimization opportunities that are implicit or inherently available because your entire workflow is visible through the CUDA graph. Okay, so just to repeat, CUDA graphs are about making your applications faster and making it repeatable, making processes repeatable and repeatable in a fast way, and just being able to take advantage of your GPU even more, and lessen the amount of overhead, lessen the amount of back end processes you have to do in order to get the work done in the application. Okay. So that in a nutshell is what CUDA graphs are and what they offer to the world. Okay, so there are three core phases in CUDA graphs. The first is a definition phase where you're basically defining your processes. The second phase is the instantiation phase, and that's where you are, doing all the overhead and the backend processes prematurely. So you instantiate the graph. And then, of course, the last piece of the puzzle is when you execute the graph. So you basically launch the graph. Okay. What are the things you could do in, or you can define in the workflow, execution, data management, launches from the CPU, synchronization. There's a whole list of things you can do, you can define in the CUDA graphs workflow. Again, as I said before, it's repeatable, so you're able to once you define the graph, you could re-execute it many times. You don't have to go through the definition and instantiation phase. You could just keep executing and executing as much as you see fit, whenever you see fit, because everything else, the overhead has been done. Now, within the graph, you could have a kernel launch, you could have a CPU function call, memory copy operations, memset. You could have graphs within a graph, so a nested graph, things of that nature. You could even have just an empty node or empty piece of your graph that's not doing anything. So the purpose of this video is really to just give everyone a very basic introduction to actually coding a graph and getting it to run. And when I say basic, I mean very, very basic. Okay, just giving you the means by which you create and launch graphs. Okay, so there are two main ways that you can define a graph. The first, and I think the most common way, I think the one that most people are using right now, just because it's easy to port over. Like if you have code that's not in, not using graphs, and then you want to take advantage of graphs, you could just use this method. So there are two methods that you could do to define and run graphs. The first method is the stream capture method. And that basically means that you're telling the system that, okay, we're going to capture everything in this stream, and we're going to make it a graph, and then we could launch the graph, right? So that's the first and I think most popular method, but I could be wrong. And the second method is the explicit API method. So the explicit API method basically means you are manually defining and writing out everything that you want to happen in your graph and in your processes. Okay. I kind of find the explicit API method to be a little bit more difficult, a little bit more involved. There are more variables that you have to create, and there are more moving parts. I wouldn't even necessarily say it's faster in any way or anything, but I guess if you want to be very direct and explicit in terms of what you want to happen when and how and all that stuff, probably the explicit API method is the way to go. So with this tutorial, with this video walkthrough, I'm going to show you a very simple example of both methods. So the stream capture method and the explicit API method, right? And all we're doing with the kernel when we run these two methods is printing a message to the screen, okay? So, by observing the code and seeing how everything is created, it will put you in a very good position to start coding whatever it is you need, right? Again, this is a very basic walkthrough. Now, I will tell you from the get-go that my example is simple, but CUDA graphs in general, it is a very capable process. It is a very involved process in terms of the things that you can do. You could have various nodes run simultaneously. You could test for whether things are being captured or not. There are all kinds of, you could step into being captured, you could step out of being captured, you could combine graphs, you could nest graphs, you could do all kinds of things. Now, CUDA graphs are still relatively new. So, obviously, I don't think anyone really, except for maybe people at NVIDIA themselves who created it, are an absolute expert on this stuff in its entirety. But the purpose of this tutorial is just to give you a very clean launching pad for you to start investigating more. Of course, there is Google, and Google is the way to go in terms of figuring out what it is you want and researching whatever direction you want to take. But here at Cuda Education, we're all about just making everyone's life easier and making that initial the initial learning curve a little less difficult. So yeah, that's pretty much my take on matters. I will now start to get into some code and you know, as we write code and go through these things, you will, you know, you will learn and understand along with me while I'm writing the code, you know, what's going on. Okay, so I just basically have a blank Cuda graphs solution here. Actually, what I will do is just to make sure everyone is on the same page. What I will do is I'll create a new project. Okay, so I'm using Cuda 10.1. Okay, I'll give you a little background on my system. I'm running Windows 10. Maybe put it over here. Yeah, I'm running Windows 10. My graphics card is a 1050 Ti graphics card. So my compute capability is I think 6.5. This is Visual Studio 2017 Community Edition. I haven't whatchamacallit. I haven't upgraded to Visual Studio 2019 for obvious reasons. I don't think it's quite ready yet for what we would like to do. So, you know, you know, once you open up the project and you have Cuda, you know, set up on your system, you get a default project, but we're not concerned with that. I just want to make sure that everything is running as it's empty. So basically, I just don't get anything, right? Okay. So yeah, this is just an empty project. Okay, nothing too crazy. Okay, so let us get started. So I'm going to create a simple kernel, and of course it's going to be global, right? And this guy, we're going to call it Cuda Education Kernel, right? And I'm not accepting any parameters in the kernel. And it's just going to be a printf, right? And visit cudaeducation.com for good health and prosperity, okay? And I'll put a new line at the end of it, okay? And that's my kernel. I just want a very simple kernel that everyone can understand, doesn't accept any parameters or anything crazy. And all I'm doing is printing out a string. And that's it. Okay, so now we're in our main function, right? And I could just compile this just to make sure there's no errors. I like to do it piecemeal. Okay. Okay. All right. So now we're starting in the main function. So we're going to say, we're going to start with the stream capture method for graph definition and execution. Okay, so that's our first order of business. So the first thing we do is we start defining variables. Okay. So we're going to start with, this is the graph variable, okay? So Cuda graph underscore t graph, right? And right, that's just our graph variable. We have to have a graph variable, and it's of this type, okay? So then now we have to create another variable. This is the variable that will hold the instantiated graph after Cuda graph instantiate is called. Cuda graph exec underscore t graph exec, okay? So we have our regular graph variable, and then we have the graph exec, which is going to be the variable that is created after this graph is after the graph is instantiated, okay? Nothing too special there. So then this is the stream variable, okay? So for now, I am just going to do stream one. I'm just going to do one stream variable. Later on, I'll create another one because I want to demonstrate some things. But so, you know, as I'm sure you know, in Cuda, all things are done in streams, whether it be the null stream or any other stream that you create. So here we're creating a stream, and we call it stream one. And for now, that is our variables that we're defining, okay? Okay, so we're still in stream capture mode, and I will just down here, so we have some organization. I'll just put end stream capture method for graph definition and execution, okay? So this is going to be our section for stream capture, okay? So we define some variables, and we're happy with that. So now what you have to do is we created the stream variable, but now we have to create the stream. So let us create, we're gonna, the stream. Just, you know, for when you are coding, always remember that you not only have to create the stream variable, but you have to create the stream itself. If you forget to create the stream, you will get a runtime error. The variable stream1 is being used without being initialized. Right? So always make sure to create the actual stream. So we're going to do Cuda stream create, and we're going to do stream one. Okay? And so we defined the stream variable, and then we created the stream. Okay? All right. Okay, so now here's where the magic happens. So we're going to begin capturing the stream for the graph. Okay. So we do Cuda stream begin capture, and we're doing stream 1. We're doing Cuda stream capture mode global, right? So this is a kind of a mode of capturing, which is beyond the scope of this video, but you know, again, it's an option that you could use depending on what you want to do. But for right now, Cuda stream capture mode global 1, capture mode global is good enough for what we want to do. So we defined, we've begun capturing stuff, okay? So we've begun capturing the stream. So then we're going to do, we're going to define our kernel. So we do Cuda education kernel. We're just going to do one block, and we're going to do 1024 threads, and we're going to setting 0 for the next parameter, and then we're going to define our stream that we're going to use. And the stream that we're going to use, of course, is stream 1. Okay, so this is just a typical kernel launch within Cuda. You should be familiar with this. We do the (0) because we're not really interested in this parameter, but we want to define that we're launching in stream 1, right? And then after that, we do, so we've defined the kernel, and then we're going to tell it that we're ending stream capturing, right? So stream 1, comma, and graph, okay? So we have now, this is where you begin the stream capture. This is where you begin the stream capture. And now we're ending the stream capture here, okay? So we end capturing stream for graph, okay? So that's it. We have captured the graph, okay? So maybe just to keep things clean, I'll just put everything together. So we started capturing the stream, we defined the kernel that we want within the stream, and then we ended capturing the stream, okay? All right, so now that was the definition phase. So now we're going to instantiate the graph, okay? And we do Cuda graph instantiate, and then now we have to define the variable that we are going to have that holds the instantiated graph, and that's where this graph exec comes in, because you remember up here we defined this is the variable that will hold the instantiated graph after Cuda graph instantiate is called. So we use this variable here to hold the instantiated version of the graph, right? And then, of course, what we're instantiating is a graph, right? And then all these other parameters we'll leave null for now, and we'll just use 0. And that's pretty much it. The graph is now instantiated, okay? So then that's it. And once we do that, we just launch the graph, okay? So we do Cuda graph launch, then we do graph exec, and we're going to launch into stream 1, right? And that's pretty much it. So just to reiterate, this is a stream capture method, right? And I'll put this a little bit closer now that we're done with it. So we define some variables, the graph variable, the graph execution variable, and the stream. And then we actually created the stream. And then we, began capturing the stream, and all that happens in the stream. In this case, we're just launching a kernel, a simple kernel. And I'm using 1024 threads because my graphics card 1050 Ti, my compute capability 6.5, allows me to do up to 1024 threads per block of per block. So per block in right. So 1024 per block, right? In the grid that I'm launching and what have you, right? So I have one block and I have 1024 threads in the block. Now, depending on the card that you're using and the compute capability you have, you might need to lessen this number to make sure you're able to run the code, because if not, your kernel won't launch. And actually, in the example code that I will put, in the ebook, I will, just make it like 10 or something, just to make sure everyone can run the code out on first glance, or most people. Okay, so right, that's it. We begin capturing, we launch the kernel, we end capturing, and then we instantiate the graph and we save it in the graph exec variable that we created above. And then we launch the actual graph. Okay, so let us see if we are successful in our endeavors. Okay, so it compiled correctly. That's a good sign. And now my code is running. So it says, visit Cuda Education for good health and prosperity. New line, and I assume 1024 of these are being are being shown, and that's pretty much it. Okay, so I am happy. The code runs. Everything is working fine. Now, this is something that happened to me, not necessarily in the stream capture phase, but it happened to me in the direct API method phase, right? And what you always want to do is to just make sure that it's actually this that's launching and running, and not just the fact that you had defined a kernel. Because sometimes, like if you forget to put in the begin stream capture or the end stream capture, and you actually define the kernel and then you run it, instead of it being the CUDA graph that's actually running the kernel or preparing and running the kernel, it's the fact that you had defined the kernel here that's actually running, right? So I say that to say this. What I'm going to do is I'm going to comment out the actual kernel launch, okay? So I comment out the actual kernel, not the actual kernel launch. I comment out the actual CUDA graph, launching of the CUDA graph. So I'll repeat. I comment out the launching of the CUDA graph because I want to make sure that when I recompile and run the code, that I actually don't get any results. Like I don't get any kernel launches or anything. So see, I don't get any kernel launches or anything, which basically is telling me that everything is set up the way it is, and that it's actually my graph that is launching the kernel. Okay, so took out back the comment, and I am able to launch the kernel, and you could see that happens. Okay. One important thing that I wanted to cover, as much as I like simplicity, I think it's important to cover is there's a variable that you can there's a variable that you could use to test whether your stream or your code or the section of your code you're in is actually capturing. Okay, so there's a process that you could use to test whether you're actually in capture mode and you're actually capturing in this part of the code and what have you. Okay, so in order to do that, what I'm going to do is I'm going to add another variable in our variable definitions, and it's type Cuda stream capture status. Okay, and the variable I'm going to use is I'm going to say, is this stream being captured? Okay, so this variable is going to tell me whether it's going to hold the answer to whether the stream that I'm in is actually being captured. Okay, so this variable holds the answer to whether the stream is being captured or not. Okay, so that is pretty much this variable holds the answer to whether the stream is being captured or not. So it's supposed to help us to know whether it's being captured or not. I will also create an extra stream variable. It's sort of a dummy, let's just call it dummy stream. Okay, so this is another stream variable. So we have the stream one, which is actively going to be captured, and the dummy stream, which won't be captured. Okay, so within our capturing code, we could now test to see if let's do test the status of the stream to see if it is really being captured. Okay, so we do Cuda stream captured, Cuda stream capturing, and we do stream one, and is this stream being captured? Right, but it's Cuda stream is capturing. So Cuda stream is capturing. Is this stream being captured? Okay. So it's going to give us a result here. So now we have to test whether that that string is actually being captured. Is this stream being captured equal Cuda stream cap status active. So you could always look up the various values that is available for this. Cuda stream capture status active, but this is going to tell you whether the result from this line of code is a yes, which means that stream 1 is being captured, or a no. So if it equals to Cuda stream capture status active, then I could do a printf. This stream is being captured, right? Okay, so that is basically our code. So again, we have our stream1 variable, which is a stream, and then we create an is this stream being captured variable that holds the status of whether the stream is actually being captured. And then we run a test called Cuda stream is capturing, and we say, okay, for stream1, tell me whether the stream is actively being captured. And it should be actively be captured because it's within the begin stream, the Cuda stream begin capture, and the end Cuda stream end capture. Okay, so let us compile the code and see what happens. Okay, so this stream is being captured, so we are correct. The stream is actually being captured, and all is well. Now, let us test it on our dummy stream. So we created the dummy stream variable, but as I've mentioned before, we also have to do, we also have to create the stream. Right, and so dummy stream. Okay, so we created the variable, and then we actually created the stream, and we're going to now test if dummy stream is being captured instead of stream 1. Okay, so let's recompile. Okay, so now we don't get a message. There's no message, which basically means that that stream isn't being captured. So within your code, and also remember, visit cudaeducation.com for good health and prosperity, right? But within your code, you could always test to see if what you think is happening is really happening. Like, you know, if you think the stream that you're in is actually being captured, is really being captured, you could test it with this test right here. Okay, so there you have it. So that is the stream capture method for graph definition. Okay. So that's the first part of what we want to do, okay? So now you have an idea of how to set it up, you know, and what to look out for. You know, you launch your variable. We'll just go through define variables, create the streams, begin capturing. You know, you could test if what you think is being captured for whichever stream is actually being captured. Launch the kernel. End stream capturing, right? So yeah, I'll just leave it as it is. And then instantiate the graph and launch the graph. And that's it. So there you have it, guys. Stream capture method for CUDA graphs. All right, a very simple example. Of course, things get a lot more involved and what have you, but this is a basic framework that you could run with. All right, so let us, I'm going to comment out this section because we are done with the stream capture method. Okay, so let us now move on to the next way of doing it, and that way is the explicit API method of defining a graph. Okay, so we want to now directly define the graph instead of just having a beginning and an end in terms of capturing the stream. Okay, so let me write it out. Explicit API method of defining a graph. Define variables. Cuda graph underscore t graph. So again, we're in familiar territory. We are just defining the graph. And then now we have to do Cuda kernel node params equal 0. Okay, so we're not having any parameters for our node. Okay, and then Cuda graph node underscore t kernel node. Okay, so we define a node, and of course Cuda stream underscore t stream 1, and we define a stream. Okay, so we create the graph. Okay, still this piece should be familiar. Cuda graph create, right? And we're doing a graph, and we'll just put 0. Again, you could look up this stuff if you want to get more involved, but we're just concerned with creating the graph. And then, of course, we also have to create the stream. Okay, so Cuda stream create, and then we do at stream 1. Okay, so we create the stream. So now we're going to indicate the kernel you want to use along with the number of blocks and threads you want to use in the kernel launch. So pretty standard stuff. Okay, so node params dot function. So for the node, you define the function that you want to use, right? And in our case, we are going to use Cuda education kernel, right? Node params dot grid dim equals dim3 1 1 1. Okay, so in terms of the number of blocks, we're just using one block, right? The grid dim defines the block, right? You guys remember your dimension variables, right? And the block dim defines the number of threads. So again, we're going to use 1024, 1, 1. Oops. Right? Type of dim3, the type of variable is dim3, and we're using, so 1 block and 1024 threads. Okay? And then node params dot shared mem bytes equals 0. Okay? So those are just your node parameters that you're defining. So we want the Cuda kernel, Cuda education kernel, we want 1 block, 1024 threads, and shared memory bytes of 0. Okay? Define the kernel node. So we're going to do Cuda graph, add kernel node, graph null 0 and at node params. Okay, so so we're adding, we're defining the kernel node. All right. So as you can see already, we're not even halfway done yet, or we still got a little ways to go. But as you can see, there are a lot more new things. There's a lot more involved. Define the variables, create the graph and stream, which is not too bad. But then you have these node params, and then you actually have to define the kernel node. Okay, and then just like in the last version, we also have to create I forgot to put it up here, the Cuda graph exec variable, right? So graph exec. Okay, so you should be familiar with that. It's the executable version of the graph. Okay, so since we have our graph exec variable now, we could instantiate the graph. So Cuda graph instantiate graph exec graph null 0. Okay, so now we're instantiating the graph, and then Cuda graph launch. Graph exec, and we're doing it in stream 1. Okay, so we instantiate the graph, and then we launch the graph. Okay, again, if you were interested, you could look up what all these parameters mean, but for our purposes, we just want to know that this is going to be the instantiated version of the graph. This is going to be the graph that we want to instantiate, and we leave everything to null and 0. Same here, we launch our graph in stream 1. Okay, and that is pretty much it. So start explicit API version of graph. end end explicit API version of graph. Okay, so let's just make sure we have everything else commented out. Define variables, create the graph, create the stream, put in the node params what we want to happen. So we want a Cuda education kernel launch with 1 block and 1024 threads. We want to add the kernel node, instantiate the graph, and launch the graph. Okay, so let us see if everything runs as we expect. All right, beautiful. So we do get it running. Okay, no problem. So we're good there. Yeah, so that is launching the explicit version of the API. As you can see, a lot more little things, but I think it gives you a lot more flexibility. Like you could define things and you could set up relationships and stuff, but this should get you started in terms of getting things going. One thing that I did want to highlight is, again, you want to make sure, like I said the first time, you want to make sure that it's actually the graph that's launching and not anything else, like not a stray kernel definition that you had lying around in your code. Because when I was learning this stuff, and I did the explicit version of the API call, I thought it was the graph that was launching, but then I realized I had put in an explicit version of the kernel in. I had put in a kernel launch within this code, within the explicit API code, and that's what I was seeing. I wasn't actually seeing the graph launch. So you want to be careful with that. So as you can see, I commented out the graph launch here, and nothing, the kernel didn't show, right? Now, if I had defined, I'm done with all of this stuff, I'm not launching the kernel in any way, right? And again, I'll just show you. Nothing is being launched, okay? Now, let's say at somewhere within this code or at the end of the code, I had put in an actual literal kernel launch, right? 1, 10, 24, nothing, no parameters, end. So I have all my code, and I now run everything, right? And I'm thinking, okay, yeah, I have set up my explicit API and my graph and everything is running. Well, when it launches, uh-oh. Oh, yeah. When it launches, you will see that it actually it actually shows that a kernel was launched, but it's not actually the graph that's being launched. It's this stray definition that I had in my code. So I could put this. I could accidentally leave a launch definition here, right? And then, this isn't actually being launched, but I think it is because of this stray definite CUDA kernel launch here, right? So you think, okay, yeah, my code is optimized because I have the graph defined and stuff, and for you guys, but actually it's not true because it's actually this being launched. So I know you guys are going to massively complicate and make things more involved and difficult and try and do a bunch of stuff, okay? And you're gonna have things looping into things and all that good stuff. But, You just want to make sure that whenever you're doing all that stuff, that it's the actual graph that's being launched and not some stray definition you have lying around during debugging. Okay? Just food for thought. And I'm sure there are graph management functions and stuff you could use to make that happen, but it's beyond the scope of this it's beyond the scope of this tutorial. Of course, guys, let me, while I'm at it, I'm gonna lower the thread count for the example code and stuff because I don't want people to not have their code run because the threads are, are too much. Anyway, guys, remember as this code says, please visit CudaEducation.com. Subscribe to the YouTube channel. You could subscribe to the YouTube channel on CudaEducation.com. Visit CudaEducation.com for good health and prosperity. That's always a good look. This is the CudaEducation.com website. You have a bunch of stuff on OpenGL, on Jetson Xavier, on NVIDIA Cuda, GPU programming, right? TensorFlow, just general tutorials, installation stuff. Subscribe to the YouTube channel. Remember, guys, when you're playing with this code, use at your own risk. This code and/or instructions are for teaching purposes only. Cuda Education does not guarantee the accuracy of this code in any way. The code and instructions on this site may cause hardware damage and/or instability in your system. This code and/or instructions should not be used in a production or commercial environment. Any liabilities or loss resulting from the use of this code and/or instructions in whole or in part will not be the responsibility of Cuda Education. All rights reserved. This code is a property of Cuda Education. Please contact Cuda Education at cudaeducation@gmail.com if you would like to use this code in any way, shape, or form. Guys, thank you for watching. Definitely check out the website for more tutorials. I hope this helped you. I hope this helped your staff to be more productive in their day. It's a small price to pay. And please tell your friends. Tell anyone in your group who would like to prepare themselves for the future. Software is where it's at. There's no two ways about it. So everyone should be familiar with programming and getting stuff done with a computer. All right. Thank you very much for watching.